So it says here the density of magnesium is 6 grams per centimeter cube less than iron. So density is a ratio, it's a rational expression of the mass divided by the volume. And it says here the volume of the two samples is 3 centimeters cubed. So together the total volume is 3 centimeters cubed. You have some magnesium, some iron. And this expression here mirrors this statement. So the density of magnesium is 6 kilograms per cubic centimeter less than iron, and it's going to look like that. And so what we want to do is write the expression for the mass of magnesium. Okay, so we're first going to start with the density of iron. So the density of iron is going to be the mass of iron divided by the volume of iron. And then the density of magnesium is going to be the same thing. Density of magnesium is going to be the mass of magnesium divided by the volume of magnesium. And this is what we're solving for. We want to know that. We want to have some expression that equals mass of magnesium. There's some other information given here. The volume of the two samples together is 3 centimeters cubed. Okay, so I'm going to write this out. The volume of iron plus the volume of magnesium equals 3 centimeters cubed. And we're going to start with that statement. The the density of iron minus the density of magnesium is equal to 6. And again, we're going to use this statement and solve for that term. Now to solve that term, we're going to get rid of some of these unknown parts. Since we can express the volume of magnesium in terms of iron or vice versa, we're going to get rid of the volume of one of these. So I'm just going to arbitrarily get rid of the volume of magnesium by making an expression, equivalent expression for volume of magnesium using volume of iron. So I can replace magnesium with 3 minus the volume of iron. And that's what I'm going to do down here. So I'm going to rewrite this expression and then solve for the mass of magnesium. So it's going to look like this. Mass of iron over volume of iron minus the mass of magnesium, that's what I'm looking for, divided by, and instead of using volume of magnesium, I'm going to use an equivalent expression using iron. That way we don't have as many unknown parts. We have these two parts referenced to each other. And that's going to be equal to, the difference is equal to 6 grams per cubic centimeter. So I'm just going to rearrange this and solve for the mass of magnesium. So I'm just going to do some algebra now. So I'm going to get the magnesium on the other side of the equation and subtract 6 from both sides. So that negative mass, I'm going to write it as mass magnesium divided by 3 minus the volume of iron. And I want to solve for the mass of magnesium. To do that, I'm just going to multiply both sides of that equation by that denominator. 3 minus the volume of iron. Those are going to cancel out. So what ends up happening is I end up with the mass of iron times 3 minus the volume of iron over the denominator, which is volume of iron, minus 6 times that, so it's going to be minus 18 plus 6 times the volume of iron, and that's going to be equal to the mass of magnesium. So there it is. I've solved for the mass of magnesium. That's going to be the mass of magnesium. Now, this is good enough. I'm just going to put this in the common denominator. So I'm just going to multiply top and bottom by volume of iron. So this is going to be 3 times the mass of, actually, am I going to end up with any terms that can cancel out? No, it's not going to be. So I'm not going to end up with any terms that can cancel out here. So I'm just going to leave it in this form. So mass of iron times 3 minus the volume of iron minus 18 times the volume of iron plus 6 times the volume of iron squared, and that's all over the volume of iron. And that's equal to the mass of magnesium. So this is just an exercise of keeping track of a lot of different terms in a rational expression.